Dheeraj Pandey. I'm the co-founder and CEO of Nutanix, and we'll talk more about what we do later on.
I'm Jason Collier, CTO and co-founder of Scale Computing.
And I'm Dave Wright. I'm the founder and CEO of SolidFire.
Gentlemen, I see scaling storage for the future. I mean, I have a background as a CIO, so I probably look at this potentially a little differently than a storage technologist. But I see scaling for the future in a lot of different ways, and it sounds like we've got a couple different ways here represented. We've got scaling up, scaling out, all the normal things. But tell me what scaling for the future means to you and what your company brings to the table a little bit.
But I think for us, and maybe a little bit for Jason as well, we tend to look at scaling the data center as a unit, and that means scaling compute and storage, and I think convergence is a big part of our story. And for us, the network is the big bottleneck. We're like, if you have to lug around a lot of data between the compute, the application, and the storage, then you basically have lost out a lot of the benefits of flash and other such things. So we collapse compute and storage, bring them together, and at the same time also scale the systems out by having some architecture tenets like no single point of bottleneck, no single point of failure, and that helps us actually go from 4-node systems to 400-node systems seamlessly.
And when I've looked at Nutanix before, one of the ways I've sort of described it is sort of you take a building block approach to the data center.
Yeah.
Very much from across the resources, so it's not just limited to storage. Yeah. Does that present any challenges with regard to being able to balance resource utilization between things like storage and disk or RAM and processor? Can you tweak the other resources enough so that you get enough of what you need as you build out the data center?
Yeah, on Friday we're going to have the TFD in which we'll actually unveil some of the new things that we're doing in the product that will perhaps steal the thunder from the marketing team. So I'll actually talk more about that on Friday.
I look very forward to that.
Yeah.
Yeah, so like Dheeraj said, we definitely look at it more as from a holistic approach. And we actually started out, selling the scale-out storage piece, and with the full intention of coming out with a kind of this what's being called the converged and hyper-converged arena, where you're actually collapsing those stacks together. Some of the inherent advantages, one of the technical advantages I'll hit on that you were talking about is networking being the bottleneck. When you stop, the absolute best thing, and when you look at a standard virtualization deployment, you've got, whether it's a large deployment or a small deployment, you've got your virtual hosts that are actually going to be out there, going to be running, VMware, Citrix, Hyper-V, whatever on it, and then you have to get all the cool features. You really need, some type of a shared storage subsystem underneath that. So the best thing that can ever happen in a storage subsystem is you get basically a hit out of cache. And anytime you're going to do that in a shared storage subsystem, there is always a network hop. There is always a network hit. Now, in basically products like Nutanix and Scale, like whenever you're going to get that hit, there's a good chance that it's in the cache in the actual local system itself. So I know for us, like, one of the kind of inherent performance benefits you get by collapsing this architecture down into basically this node-based scale-out system is when you get a cache hit, it's coming out of RAM on the local box instead of basically having to do that network hop and that traversal, which actually does bring those little bit less latency and get you better performance on gear than you'd normally think, because you're kind of eliminating that one particular piece. Now, one of the other things I see from the convergence space is scale out is effectively what's driving it. When you need to basically adjust resources, you can, there are always ways you can individually adjust those resources, but then always, kind of keeping those things in balance by basically adding nodes and having the scale out capability to basically add different node types, mix and matching different kinds of nodes to get that overall aggregated architecture and feel. That's a few things that are going to be beneficial in this. It's a few things like on our longer term roadmap is to actually have different styles of nodes. So if you need more compute, add kind of a compute brick. If you need more networking, add a networking brick. And going with that kind of approach to give you a little bit more detailed and granular focus on that. But it's what we really do today is focus on delivering those more mid-market solutions. So if any of you were in on the panel before, I said what we do is we sell Toyota Corollas. If you need a Ferrari, we sell Toyota Corollas. And that's really, the focus for our market. Those are what the guys need. They need the Toyota Corolla, not the Ferrari. If they need the Ferraris, then you can get into basically tuning and doing some of the more advanced things. But really, we try to focus on that specific subset of a customer where that's exactly the car they need.
David?
So, when I think about scaling storage for the future and what exactly that future looks like from the perspective of SolidFire, we're really looking at this transition from standalone kind of siloed bare metal architectures to virtualized architectures to cloud architectures. And as you go from a virtualized infrastructure that maybe you've got an ESX cluster with 32 hosts, and that's a big ESX cluster, to a cloud architecture where you might have 32,000 hosts or 32,000 cores in 8,000 hosts. There's a whole different level of scale there. And with that level of scale, obviously you need a different architecture, different type of infrastructure behind it on the networking side, on the storage side, and if you look at not just the architecture of that storage, but the functionality and capabilities that it provides out to be able to support that kind of scale, there are very different things that you need to be able to do, because things like troubleshooting at that scale are very different. You can't have somebody look at a dashboard that shows you the performance of that many hosts, that many virtual machines, and actually make any sense of it. So when you talk about going to cloud scale, going to the scale of thousands and tens of thousands of hosts and virtual machines, things look very different. And that's really kind of what we're focused on helping people solve.
Yeah, if I might add, I think the one piece that is really important to scale storage for tomorrow is how do you scale metadata and how do you scale the cluster manager? And I think as we go deeper in this discussion, we might actually open it up for what does it mean to really scale metadata to go over hundreds or even thousands of nodes and so on. And the same thing with cluster manager, and how do you do health notification and configuration databases and failures and handling events and things like that.
No, Stephen, I've never heard you stay this quiet for this long. So would you like to jump in?
Sure. Yeah, I think that there's, well, let me start by saying that in my opinion, scaling storage, and I mean really scaling it, not just piling it on, but really scaling a storage system is probably the biggest technical challenge in storage. And I think that a lot of people who aren't, storage people don't understand that. They think that this should be easy. And I see this in the server space, in the network space. I mean, how do you scale a network? Well, you've got a bunch of autonomous nodes that all work together because that's how networks work. But storage doesn't work that way. And that's why I'm so interested in basically what your companies are doing, because you guys are trying to solve this problem that is effectively, I don't want to say impossible, but it really isn't practical and easy to solve how to scale storage, especially if, as you guys talked about in earlier sessions, if you're going to stick with the same existing protocols. How do you scale NAS? Well, you go to something like PNFS. Well, what if the clients don't support it? Well, gosh, I don't know. You gotta figure out some way of kind of hacking it. Like Isilon. How do you scale block storage? Well, you don't. How do you do it? Well, you got to figure out some way of making it work, of hacking it to work, and it's really amazing to see the variety of approaches, but it's not something you can just wedge into a system.
Yeah, also the workloads are changing. If you look at PNFS and the SpecFS benchmark, 85% of SpecFS was metadata. It was reader plus, and link. And
why is that? Is it because that's what people could do?
No, I think it was because back then when we had physical machines and the clients of the NFS server were supposed to be desktops and workstations and so on, you had to manage 2 billion entities, right? Small files, 2 kilobyte files to 2 petabyte files and everything in the middle. Now with virtualization, the problem statement has changed. You're saying you don't need to manage 2 billion objects. You're supposed to manage 10,000 very large objects, but you need to go and show some love to every of these objects in terms of IOPS. Each object is a virtual disk, and you need to snapshot them independently, you need to back them up, you need to have DR policies of them independently, you need to actually have very good IOPS on these individual files. And that is an inside-out kind of a problem statement, very different from what it used to be when the isolons and the 3PARs and the others were actually really designed.
And I think that gets, I don't want to steal the thunder from the next session, which is all about virtualization in cloud, but that gets to sort of the answer to scaling storage is you've got to do something fundamentally different.
Yeah.
To really scale, you can cluster, but in order to really scale seamlessly as you get really, really big, you've got to do something different. You've got to have a virtualization
workload. I mean, all of a sudden the workload is virtualization. You're saying, my client is not the guest virtual machine. My client is a hypervisor, and the objects I manage are these 10,000 objects, which make up for a very large data center.
So it's like a tiered system, really.
Absolutely.
So the storage array is one tier, and then the hypervisor is sort of the next storage array.
Absolutely.
And then, or the hypervisor cluster in the case of, how it would really be implemented. You'd have multiple hypervisors running on multiple machines, and they all cooperate. And that's the next tier. And then the machines themselves are actually a third tier. So we've really injected a whole layer in here.
I think that's well said. The level of aggregation, the file systems like NTFS and ext4 and so on and so forth, they're managing millions or managing billions of entities, but they're sitting inside the guest. And what the next generation storage appliances will have to manage is these 10,000, 20,000, 100,000 entities, which are big. You need to do really well in terms of sequential I/O and random I/O on individual files, and you need to really love them with respect to individual backups and snapshots and DR and things like that. Because that's what the guests are looking for.
And it's really, and virtualization as a whole has kind of changed, and we see this in this hyperconvergence space all the time. Has changed from what a lot of these things were initially intended for. What POSIX-based file systems were intended for. What basically the NFS protocols, Samba protocols. Even the different block level access protocols that are accessed. Well, virtualization is a different fundamental workload than what these protocols were designed for. I mean, when VMware is in there and they're start supporting the like NFS and stuff like that. I mean, NFS wasn't designed to run that workload. Like that workload didn't really exist. Well, it kind of did. It just in like the mainframe space, but it was really this is a new problem and a new approach, and really this is where the storage piece of that subsystem needs to evolve to be something that's more suited to run that virtualized environment.
And that's why we need things like VAI and ODX, just because the protocols were never intended for this kind of workload. They were never intended for, as you're saying.
So you guys are basically building the train while we're moving forward. You're building all the framework around making sure all this stuff works the way it's supposed to. It stays on the rails, even while you're trying to get us to a point where we can scale our storage to the kind of levels we need in the future.
That's well said. I was talking to Anil before I came to the panel, and I said, look, people talk about object storage all the time. But there's lots of applications that need today's workflows of snapshotting and cloning and flex cloning and DR and backups. And those things are not going away for the next 10 years. So we've got to actually bring that NetApp goodness to the next generation architecture while we think about how it's going to be with objects. And because today Hadoop is an object-based file system. And it's useless more than just big data, right? I mean, you can't just run your SQL Server against HDFS or something, right? It doesn't have any of those things that require you to actually have a CIFS-like compatibility or POSIX-like compatibility.
So what I'm hearing sort of is that when we're looking at scaling, we're not necessarily looking at how many terabytes or petabytes or IOPS do we need, but it's what are the challenges around getting to the next level, like the metadata pieces and things like that. That's really what you focus on, because is the capacity and the IOPS piece easy?
I don't think so. I think there's challenges across the board. Aggregating capacity has gotten a little bit easier as you've gotten more disks, but even there, there's challenges with RAID and the limitations of RAID as you get to very large capacity disks and long rebuild times. So even something as simple as giving you a lot of capacity has inherent challenges, and the move to scale out object-based storage systems with erasure coding is a great example of how people are solving that capacity scaling problem. The performance scaling problem is completely different. Again, we've got lots of raw performance with flash, individual drives that can do 10,000, 20,000, 50,000 IOPS or more. But the challenge is, how do you scale that? How do you go from 50,000 IOPS to 500,000 IOPS to 5 million IOPS? Because there's a lot more above the level of that drive that can be bottlenecks very, very quickly when you have that. We talked in an earlier session about the bus limitations, the front end bus, the back end bus, how quickly that can become bottleneck. The storage controller that's potentially sitting in front of that drive, especially if it's trying to do things like deduplication and compression, how quickly that can become a bottleneck, and then the network itself. So all of these things make it difficult to scale performance. And I think when we talk about scalable storage systems and scaling systems for the future, if you look at what the characteristics of a scalable storage system are, one of them is simply that it scales in such a way that you're not simply adding more devices, more drives, more capacity, because you can only go so far with that, especially with flash. You have to have a storage architecture that gives you linear scalability on the entire system and all of the things that could potentially be bottleneck, whether it's cache, whether it's the network interconnects, whether it's the CPU power that's being used on the front end. All of those things have to scale linearly, and then you need an architecture that allows you to distribute the load, distribute the data evenly over that entire thing, because if you don't distribute it well, and again, this is one of the big challenges with scale-out storage systems, if you get a hotspot and that hotspot becomes your bottleneck, even though you may have lots of performance in aggregate, if you can't manage that properly, then you've lost all the benefits of being scale-out, and it's actually worse than it was if you had siloed those applications.
I think Dave also hit upon a relatively unsexy area in storage that most people don't talk about. It's the control path. It's like, how long does it take for you to rebuild a drive? It's like at scale you have problems with that. Are you going to be able to survive a second failure while the first one is actually rebuilding? How quickly can you add like 50 nodes in the system? How quickly can you remove nodes from a system? Can it be done online? There's a lot of control path scalability issues that come in. Is your serviceability framework scalable? Is your manageability framework scalable? At the end of the day, your UI has to scale. There's a lot of those unsexy things that people don't, because everybody is just so enamored by performance that those things don't even come up.
Well, let me expand on something you just mentioned. You talked about UI performance and manageability. As these things scale, and there's a lot of complexity there. I totally understand that when you're looking at wanting to scale, regardless of how you're going to scale. But one of the things that people are clamoring for, I know I spent 10 years in a CIO chair, and what I didn't have was a lot of people. And these things got to be easy to use. There's a lot of complexity behind these systems, and especially as you start scaling them out and you have to do all of this work. I want people to be able to just run it.
Yeah.
What kind of challenges do you face as you scale up and out from a user, from an administrative perspective? Because I don't want 5 people having to manage my storage.
So I think one of the challenges is that storage has historically been a administration and administrator-centric technology. It has been built from the perspective of a storage administrator who manages a storage platform. The problem is storage administrators don't scale.
No.
The storage system may scale, but a storage administrator sitting in front of a dashboard with 20,000 virtual machines and he's trying to figure out what's going on and how to manage that capacity, that's never going to work. He can't scale. And you can't get enough of those very highly paid people to do a good job of that, even if the storage system itself could. And so the answer is the only real way that you can scale that is through automation and to pushing the management out a further layer than the storage system, because if you try to manage everything through the storage system, you're going to fail. And so, our focus has been on the APIs and the automated management of our storage system. And yeah, we have a GUI and we have a CLI, and our customers, when they first go to deploy, they're going to use those things. But when they get to scale, if they're still using those tools, they're doing it the wrong way. The right way is to use our APIs, use the integration we've done into higher level cloud and orchestration frameworks, things like OpenStack, CloudStack, VMware, that are pushing then the provisioning, the management of that storage, potentially all the way to the end user, potentially all the way to a dashboard that a business administrator has that says, I want to push a button and deploy this application, or to a service provider's customer, an API that they're using that says, I want to deploy this compute with this network with this storage. And that storage administrator's job now is radically changed. He doesn't have to think about, hey, there's a ticket that says I need to provision this LUN. That's completely taken out of the picture entirely. He's looking at the big picture. What's the overall performance and capacity levels of the storage system? What's my growth plan? How am I kind of stamping this footprint out as I grow? And they don't have to deal with the day-to-day minutia anymore.
I totally agree. I think, and this is a real good point, because as hard as it is technically to make a storage system be real big. It's just as hard, you know, the biggest storage management tool has always been Excel, right? Because people aren't, you know, keeping spreadsheets of every single LUN and all the LUN assignments and everything, because that's how we manage fiber channel arrays. I wrote about this a few years ago. I said, you know, how I, you know, learned to stop worrying and love automation, because you have to give up. You have to step back as an administrator. I mean, not you guys. Please don't give up. But as an administrator, you have to give up, and you have to step back and say, I'm going to let this system manage itself without me. I'm going to let it decide where to put the data. I'm going to let it, and it's the same with something like DRS in VMware. One of the things that in my seminars, I caution everybody, you know, even though there are all the rules for DRS, affinity and anti-affinity and all this kind of stuff, I tell people don't use it unless you really have to. Because the more you constrict automation and the more you try to second guess the system, the less benefit you're going to get. And at a certain scale, it just isn't practical anymore. The only way to have a system run is to let it run and let whoever designed that thing make it work.
The best sysadmin I've ever known said his entire goal was to automate himself out of a job.
I used to have an IT director that I worked for who said that our goal was to put ourselves out of business. It was basically automate as much as we can and focus on value add to the business rather than value add to the data center.
And it's so hard to do that.
It's incredibly difficult.
This is a very profound question that's brought up about simplicity and usability. I mean, you can see there's a BlackBerry, there's an iPhone, and usability has gone into this, you know, $500 billion company as the core goal. I mean, that's the one mission that they have is usability, right? And we've seen so many others actually try things, and so at the end of the day, it's a very nuanced, you know, solution. You need to actually be passionate about simplification. What does it mean to cut out things that people don't need? And just go and solve the problem for 80% of the guys, because the last 20% will need a lot of bells and whistles.
Well, it's hard for nerds like us to embrace that. I mean, we don't like easy things.
But here's the thing: I wouldn't even necessarily point the finger at the storage administrators and say, hey, these guys don't want to automate themselves out of the job, or these guys don't want simplicity. They want all the knobs and whistles. The reality is, look at what they've been given. They've been given a storage system that, frankly, is too complex to automate, even if it had an API associated with it. And trust me, NetApp has an API, but the document is several hundred pages because there's so much complexity.
It's got 1,000 features.
I've got volume groups and RAID sets
Well, they have
and
an
virtual
API,
volume
but
sets.
it's not autonomous.
Well, no. But again, there's too many decisions that need to be made to do anything to put that autonomy there.
But you know what the problem is? The problem is that vendors try to be all things to all people. It's
Well,
like NetApp was such a simple system to use when it was just NFS. And then they tried to go and do fiber channel and FAS and everything else under the sun because they had to look like EMC. They didn't realize
that's part of it, but it's also if you focus on an architecture up front that has simplicity as a requirement, as opposed to, you know what, we're going to trust that we have storage administrators that can follow the rules and use this thing correctly.
I think it's before architecture, it's a product definition. Who are you going to cater to?
Yeah, no, that's what I mean.
You need to know what not to be or who you don't want to go and try to appease. And once you do that, I think a lot of things actually.
Our number one design tenet when we started creating our product was simplicity. That was the number one design goal, because especially selling in, I mean, we're talking about you got to eliminate that complexity at scale, but you also got to eliminate it down at the very bottom of the marketplace, like in that SMB space, because that guy, you got 0 to 5 IT guys that are working there. None of them are storage experts. None of them are networking experts. None of them are server experts, because they are effectively the jack of all trades. They have to know everything, and the more automation and complexity you pull out of that, then that gives them, they can go from being the mechanics, you know, who basically you can build the car with basically here's your engine, your transmission, your wheels, and then book and learn how to put it all together, or you can just go out and buy an automobile. Then they can focus on
vendors
driving.
don't solely own this problem,
right?
Because I think end users also own some of this problem. The reason I say that is, when I, as a CIO, ask an end user, what kind of requirements does your application have? The answer is, I don't know. So we're left to guess. The storage administrator will have to make a best guess, and I think you see some tools coming out that can help with that these days.
But I mean, that's a perfect example of taking the understanding that that those decisions can't always be made ahead of time.
Right.
And building into the storage architecture, we've designed our system so that when you provision a volume, you set an initial amount of capacity and performance. But if you got that wrong, you can reset it like that. You can change it. You can go from 1,000 IOPS to 10,000 IOPS and right back down in a matter of seconds through an API, through a front-end console. You can see that your volume or your application is running slow, or you had a spike in traffic, and you can adjust it. And again, that's something that we fundamentally had to build into the architecture, very early on. It's not something you can easily bolt on later, because when you start bolting on things like that, that's where that complexity comes from, right?
Right.
And look, at simplification is an armchair topic. We can sit here forever. There are no benchmarks. There's nobody in the industry.
We can actually only
says,
sit here for 14 more minutes.
Yeah.
there are no benchmarks that says you should be able to add node 10x faster than that cluster versus that scale out and so on. You should be able to rebuild disk. Yesterday we had a very funny blog that our VP of Sales wrote about EMC and the FUD that they actually put out about us.
Well, you're succeeding when the big guy notices you.
In fact, it's all over. It's like NetApp, EMC. They're all having these FUD sheets now against Nutanix. And it was about some of these things. And we said, well, let's just throw it open in front of EMC and say, well, if you want to fight a battle with us about rebuilding failed disk, let's just do that. But there's nothing out there. Everybody keeps talking about IOPS and megabytes per second, but there's nothing to say what about the control path and what about usability and how many clicks before you get a data store up and running.
Yeah, obviously the performance characteristics are important, because without that, nothing's going to work. But sitting in my chair, it was frustrating sometimes when I just couldn't get something done. Yeah. Because the system made it so darn hard to do.
Well, I think one of the things too that I want to bring up here in terms of scaling is starting small. And it's one thing to have a system that can become huge, but it's a very different thing to have a system that can start small and become huge. So, you can build a massive system, but can you build a system that grows? Yeah. And can you build a system that grows linearly?
Yeah. I think it's a very important point. The biggest thing that when you need to grow, you need to figure out how do you redistribute and repartition the metadata. Because that's painful. If you have an architecture where you have hashing of metadata keys, and you're saying, well, to add a fifth node, every other node has to give up 1/5 of its keys to the fifth guy, you have pain points right there in your add node architecture itself, because it's going to take you 3 hours to add one node or something, or there's going to be a lot of perturbation in the cluster, performance is going to slow down. So even at that level, you have to say, well, am I using consistent hashing, in which case only the neighbors have to give up their keys as I add a new node in this token ring or something? Or am I actually... Yeah, there are all these techniques to figure out how to really scale clusters, and at every step of the way, you have, and the architecture comes back to bite you because you didn't think this through. You said, well, at 4, if I add a fifth one, it takes me 15 minutes to add a fifth one. At 50, if you add you might actually take 5 hours to do that because you had this painful rehashing scheme to really go and redistribute your metadata for the 51st node.
And I think that points to not only the complexity of building a scalable storage system, but why it's virtually impossible to add scale out or add scalability down the line. And it's interesting because I think you're seeing a number of next generation storage vendors, including flash guys, who are saying, hey, we will be scale out in the future, or scale out is a roadmap item for us. And I don't know if they realize how hard that is to not have built that in to begin with. I don't know that there's anybody in the history of storage that has taken a standalone storage system built scale out. NetApp bought a company, it's still taken them 10 years. 10 years to do it, and it still isn't quite there. So.
And to take some more mundane examples, like when you add a 51st node, how do you rebalance the data? How long does it take to rebalance from 50 to 51? It's a big data problem because you need to figure out how each of the other 50 nodes are contributing and giving up some of their data to the 51st guy and so on. Same thing with metadata. All these things, like at Nutanix, we use MapReduce jobs for everything, to rebuild failed hosts or rebuild disks or to rebalance data when you add and remove nodes. We actually use this massively parallel framework to really go and do all these things, to do a lot of heavy lifting of data when the cluster state is perturbed, when the state changes from n to n+1 or n to n-1 and so on.
Do we have a question?
Yeah. Yeah, so well, I mean, this speaks to what both Jason and Stephen were talking about, which is how do you build something that scales from something that's really small to something that's really large? But not only that, when I come from that, and I know that all of the storage vendors have this problem. Let's sell into SMB space. Well, whatever we design and architect for that space is never going to scale to 150 nodes because of the nature of the requirements for SMB space is so vastly different.
Well,
Right.
I think the four node cluster has been proved to work. So Isilon has sold 4 node, 8 node clusters. They were scaled up. They were not like real scale. I mean, thin nodes, but they have gone from 4 node clusters to 64 nodes at least.
Right,
if not
and,
anymore.
Can they scale past that? Probably.
Yeah, I think beyond that, even the Fortune hundreds of the world actually put a question mark saying, should we break it down into 64 node pods? Because there's an issue of fault isolation and fault domains that's built in. I mean, look at Salesforce. Salesforce is not one big Oracle. It's 12 Oracles. And every time they add more customers, they add a 13th Oracle and a 14th Oracle. And that pod system keeps them at least such that if one of them fails, 1/12 of them are still, or 11/12 of them still alive.
It is difficult. I mean, it's definitely a difficult problem, and it's also one of, I think kind of even a little bit more of just like strategic focus for the company. I mean, we don't want to grow into an enterprise company. That is a very different product and a very different sale. So like, our UI for managing basically the storage and virtualization piece is extremely simple. That's not going to scale to like 2,000 virtual machines running on that. I mean, it is built to run, effectively those 100 VMs and down, because it would, even that whole thing of simplicity and usability is a different definition at basically a certain scale. So I think there needs to be a market where you've got, a product that fits, in there. And like I said, ours is really, focused more on that down market stuff. And it's like, I would not, if you came to me today and you're like a 10,000 person company and you want, like 4,000 VMs, I wouldn't sell you the product. I'm like, I don't care how big the check is. Product wasn't built for it.
Right. The companies who sell enterprise stuff, though,
Yeah.
think about it exactly backwards, because they're like, oh, well, this enterprise customer has all these satellite offices that
Yeah.
have very different requirements.
It's
I
very
can
different.
Strip out some of our features and sell it.
Exactly, and that doesn't fly well either. I mean, when you talk to the guys that are down in that space, because like just stripping the enterprise features out, guess what? It didn't strip out the complexity.
Right.
That's still the piece that's there. When you basically just pare down the features, it's still way too complex for those smaller environments.
Yeah, and I think in those environments, the requirements change. Like at some level, they'll say, do you have a single pane of glass that can manage 50 clusters,
Right.
which are small 3-node clusters? And that's a manageability requirement that actually comes up, all the time.
Yeah.
Question?
So, I don't think that you necessarily want to try to scale out linearly. You want to do it hierarchically, like you were talking about how Salesforce does it, where you want to scale to a certain extent. And
Yeah.
take that.
Yeah, even Google File System is not one system. They call them cells, and the cells are like 1,000 node cells. So they have lots of cells that actually make it look like 500,000 boxes or something.
Yeah.
I don't think that anybody has any request to make it look linear. The request is to make it look linear to a certain extent, and then give me an easy way to replicate it and oversee what I've done. And if I need to go up another layer, I can.
I'm sure the only ones like that are the 3-letter agencies that we won't mention.
Yeah, in fact, the way I would look at it, I mean, again, I came from I would say a large SMB, small mid-market space, was I only want to see that. I just want to see, what do I got?
Yeah.
And what can I do? I've got an app that I need to deploy. What kind of resources do I have available to deploy it? And then basically the tools to deploy it in the way that it needs to be deployed.
And that's part of where the higher level orchestration frameworks work to aggregate multiple pools of underlying kind of capacity, both compute, storage, and other things, and place the workloads and handle that appropriately so that a lot of that can be made transparent within a single system. There is a limit to what people need, but the thing that we've seen in the field is that limit is different for different people. Some people say, we want our fault domain to be this big, or we want our pod to be that big, and there's a wide range there, and you need a product that can address that wide range and allows them to start small and grow up to whatever their maximum capacity is. Because if they have to put in that maximum capacity to begin with, and then fill it up over 3 years, their utilization and their effective cost is much, much higher. So
Yeah, I think the gentleman basically brought up the point that you can't be another extreme where every node is in one cluster, because at the end of the day, even those clusters can fail all at once. And you really want to actually still have this middle ground where you have mid-sized clusters, 200 node, 400 node clusters, not like 2,000 node, 4,000 node clusters.
Other questions? There we go.
So, considering this, this clouds, what's called open cloud.
OpenStack?
OpenStack.
Mm-hmm.
Cloud stack.
Cloud stack.
Cloud stack.
Cloud stack. Where they are proposing zones and pods and clusters. So, and then that is supposed to be going into a scalable mode. Any comments that?
Yeah, no, I mean, I think that's the ideal way to do it, because you develop a logical model that gives you certain guarantees and characteristics, whether it's physical proximity, whether it's fault isolation, whether it's other things like that, and then you build up your infrastructure under that model. And again, the size of those zones, pods, clusters, whatever, it may depend on a lot of different factors. How much capital you want to deploy at any one time, the size of your data center, your power characteristics, how you're building that. And so that's the right model to have, but you still need a lot of flexibility on the underlying infrastructure to be able to build out under a model like that.
Yeah, I think my take on OpenStack and CloudStack is that we don't see it. Still, this is 18 months out. For a lot of the folks that I talk to, they say it's intellectual masturbation. So let's just move on. When the time is right.
People said the same thing about Linux in the 1990s. So.
Yeah, so I think the next 18 months, for the next 18 months, it will be vCloud Director, it's going to be SCVMM, it's going to be the big guys who actually own a lot of, it's going to be VMware, it's going to be Microsoft. And for KVM, I think it's still very early days. So we'll
Howard, you had a question?
Well, the problem I've had frequently with scale-out architectures is that they really only scale in one dimension. That there are frequently, I decide that I want to run a scale-out architecture because I'm dealing with a client and that both performance and capacity requirements are unpredictable.
Mm-hmm.
But the client then ends up maintaining huge amounts of stale data on this system. And I want to scale in capacity without paying for additional performance, the way a scale-up system would let me just add a drive shaft.
Yeah, I think you have a very good point you bring up there, and I think it goes back to scale-out systems not being built with heterogeneous nodes in mind. Because if you had heterogeneous, and what our architecture gives us, because we run inside virtualization, we can make heterogeneous clusters look homogeneous. Because you can have the same number of vCPUs and things like that for our controllers. And yet, we can run in these hardware boxes that are bottom heavy and top heavy and mix and match them in the same cluster itself. So what I actually spilled the beans a little bit, but on Friday you'll see some of that coming from Nutanix, where we'll talk about heterogeneous clusters in the system.
We are just about out of time. Can each of you provide some parting thoughts about this particular topic?
Yeah, so obviously this is a topic. Scaling storage is clearly a topic that's near and dear to my heart. But I think it's fundamental to the future of storage, and we started this day talking about the future of storage. And the reason that scaling I think is so important is because we are moving to a future of storage and to a future of IT where this is all being done at scale, where the small scales begin to disappear or really not matter. And the large scale is really where all of the new workloads are being deployed, all the growth and opportunity is. And so the better and the faster we can get good at doing storage at scale, the sooner that future can be here.
And I think scale out is the future. Okay, there's always kind of continuous argument about that, but I think as applications that are developed start becoming more and more developed for those kinds of scale out architectures, you're going to see more and more adoption of that, and that's going to then, I guess, broaden the adoption of scale out architectures, which is then going to basically give it the more ability to scale that storage environment and the compute environment and the networking environment. So when you really look at the kind of this whole converged data center play, that's going to be one of the big things that's pushing scale, because now when you think about the scale out piece, you're not just necessarily scaling out a storage component, you actually start looking at your data center by the individual components. Like, what is my CPU capacity in a data center? What is my storage capacity in a data center? What is my networking capacity in the data center? And finding out how those things level out and being able to tune that data center with different hardware platforms or virtualized platforms is basically where the industry is going to head.
I think for us, scale out is a means to an end. It's not an end in itself. Eventually, it has to drive the economics of data centers in terms of, well, we can start small, you can grow as you grow your Salesforce licenses and things like that. 1 month, 1 user at a time. Similarly, you can do the same with hardware. And scale out is all about not just, as I said, the data path, but also the control path of usability, simplification, how quickly can you snapshot things, how quickly can you add nodes, remove nodes. So there's a whole control path element to it, which is just as important.
And I think that often when people confront a topic like scale, they think that it means huge. It doesn't. It means whatever. It means flexibility. It means whatever your perspective is. You know, whether you're a little company or a huge, you know, service provider, you look at it and you say, this system, I can't deploy a fixed system. I have to deploy something that's going to grow with me, whether it's from 1 employee to 10 employees, or whether it's from, you know, 1 continent to, well, not 10 continents, but you know what I'm saying. You know, I mean, I think it's got to grow. And like you said, this is not a feature that people are going to go looking to buy. People aren't buying scalable. They're just going to expect it. They're going to want it. They're going to need it. And it's one of those things where every single customer is going to look at the market and they're going to say, this system can grow with me, this system can't. Which one am I going to buy? And I see this in other areas as well, outside of storage. I see people looking at more modular systems, more flexible systems, because they realize that, you know, again, whether they're small or large, they need to be able to grow. And they need to be able to grow without just ripping out everything and putting in something new. So I'm glad that people are tackling the technology changes and the management changes, but I think it's important also to remember, you know, what are people buying? People are buying some other feature.
Yeah, I mean, as you said, scale out is empowerment. It's about, well, can you start small and then just flexibility of growing as you go.
Thank you very much, panelists. Thank you for watching.